2019 Toyota Tundra. So as we stand right now, our temperature out of the dash, we're getting as low as actually 38. If I can zoom in there. There we go. Where it says supply, dry bulb temperature, 38 degrees out the dash. And over here to the testo gauges, you can see it cycling up and down. So I have one in the rear, and that's actually this one right here. We're 39 degrees coming out of the rear cabin area in this Tundra. We're getting down to 34 degrees out of the right duct. So my temperature over here, that is 38 degrees. That is the center duct position. The one over here, oops, let me get down. The one over here that is getting down to 34 degrees, that is out of the passenger side duct over there. Out of the rear is 38, so I'll show you the positions, the difference, the temperature. Different ducts don't always give you the same temperature. So this is the one that's giving 34 degrees out of this duct dash right here. This is the one that's giving 38 degrees coming out of this duct dash over here. And was that the one that was giving like 37 degrees over there coming out of the rear? Now remember, when you're doing your testing, of course, usually all the doors are open, everything, windows, stuff like that, but I'm not going for a go. I'm just going for minimum right now to see what its best condition can be with zero load on it. Open these, both these ducts were closed. Remember to open these to have the maximum airflow over the evaporator, to load the evaporator as much as possible with airflow. If you close these off, you make a restriction and less airflow goes over the evaporator. So always remember to come to the rear of the vehicle, because this is one that uses one evaporator and it has long ducting work through the center of the dash console, coming underneath the console in the center and coming out here. It's not a dual evaporator system. So just showing you guys a Toyota Tundra 2019. So you can see it going through its cycle on and off. Watch the low side pressure. This is a cycling clutch. This has a clutch and it actually cycles. This is not variable displacement with a clutchless. So you'll see this large swing going up and down. And the one thing, different operating conditions will cause different scenarios on your high and low side gauges. And like if we come over here, I'm taking the temperature drop across the evaporator. So here's the inlet from the condenser going into, not the evaporator, the condenser. Here's the inlet pipe from the discharge of the compressor to the inlet of the condenser. Here's the outlet of the condenser, the liquid line here. And that's these temperatures right here. 72 degrees. 72 degrees is the liquid line temperature right now. That's this bottom little liquid line right here. The 106 degrees is the vapored hot gas discharge from the compressor. And so that gives you the drop across your condenser. Now, if this drop was something like, let me give you an example. Say our discharge temperature was 150 degrees temperature, but we were 72 degrees, we would have like an 80 degree, 90 degree difference in temperature dropping across the condenser. That would be bad. That would mean we would have a restriction, some piston ring material or something like that. Something is restricting, causing a huge pressure drop across the condenser. That's one of the most common scenarios. When you see more than 50, 60, 70, 80 degree temperature drop between the inlet and the outlet of the condenser, that usually means something is wrong. And on these modern condensers, you'll see as low as 15 degree temperature difference, 20, 30, something like that. Older condensers, you had a higher temperature drop across because they were less efficient. I'll have to do a separate video on that. Alright guys, I'll catch you on the next video. See you later.